So chromium reaction, chromium, normally the oxidation number of chromium, the common oxidation number, either it is +6 or it is +3. Normally plus the color of the +3 is green in color, where +6 is orange in color. So chromium +3 and then chromium +2. Reducing chromium, here the term reducing means that we should decrease the oxidation number of a chromium. So chromium +3 and then chromium +2 are formed by reducing a dichromate, which is orange in color. Why it is orange in color? Because of chromium oxidation number is +6, and when it is +6, it is orange. Its dichromate is orange in color and chromate is yellow in color. So if it was CrO4, in both compounds, the chromate and dichromate, Cr2O7, with the charge -2, both compounds, the chromium oxidation number is +6. One of them is orange, dichromate is orange, and chromate is yellow in color. So what happened? How we can react? We can react with by strong reducing agent, which is zinc in hydrochloric acid. So when and iron 2 is less strong reducing agent, so it will only reduce dichromate to chromium +3. So example, and we can also work out using an electrode potential. When we work out the electrode potential, like when you check the reaction here, first chromium or dichromate, it changes from +6 to +3, and the zinc, which was zinc atom, it changes into zinc ion. So zinc is oxidized, whereas chromium is reduced. And zinc, why it is oxidized? Because when we check the electrode potential in this case, its electrode potential is higher, so it can easily reduce the other substance. And same way, when we check for the second, so chromium dichromate, it will change to chromium +2, and then zinc will change into zinc +2. With iron, only chromium 3 can be produced, because iron is a less like weak reducing agent, so it cannot reduce chromium to lower oxidation number, which is +2 or +1 even. But there are some common oxidation numbers for each element. So the chromium Cr2 state, which can be stabilized by forming a complex. Like example, because some of the reagents or some of the ions, their oxidation numbers for transition element, their oxidation number, they're not stable. So how we can make them stable? We can make them stable by either forming a precipitate or a complex. So what happens first when we add a zinc and hydrochloric acid? So zinc can change into chromium 3 dichromate, and then dichromate into chromium 2. So when it converts this dichromate into chromium 2, chromium 2 can easily be oxidized by the air. So if chromium 2 can easily be oxidized by air, so chromium 2 will oxidize by air and change into chromium 3. So we want chromium 2 only. So how we can make this chromium 2? So the chromium 2 can be stabilized by forming a stable complex with a ligand such as ethanoate ion. So if blue Cr+2 ion are bubble through sodium ethanoate, then the red precipitate of chromium through chromium 2 ethanoate is formed. And the Fe2 plus chromate in acidic solution, the reaction is used as a quantitative redox reaction and does not need an indicator. Why it does not need an indicator? This is called a self-indication reaction, because the orange color will change into green. So we can identify that the chromium has changes its, or there's a change in color of a chromium. So reaction occur. And you can see also in the solution iron 2 ions are there, changes to iron 3. So iron 2 and iron 3 also have different colors, designs. Is it clear? The reducing chromium, like how we can reduce chromium, we can reduce chromium to lower oxidation such as chromium 3 or chromium 2. If you use a strong reducing agent such as zinc, in the presence of hydrochloric acid, it will reduce to lower oxidation number. But that lower oxidation number, chromium plus 2, is not common. So it will return back to chromium 3. How we can stabilize that? We can add ethanoate ion, so sodium ethanoate, so which will form a complex and it will make a precipitate, in which the chromium will remain plus 2. Is it clear?
Yes.
So you have to basically memorize the chemistry of a chromium. So the highlighted, the shaded part, just copy that. Okay, oxidizing chromium. So how we can oxidize a chromium when transition metals in low oxidation states are in alkaline solution, they move more easily oxidized than when they are in acidic solution. So whenever we want to oxidize the substance, we normally oxidize them in an alkaline medium. Like example, if you have a complex of a chromium, this is a complex of a chromium, the valency of chromium is plus 3. In this complex also, the valency is plus 3. Both complex, the valency is plus 3 because it is Cr and H2. Water is a neutral ligand. So water does not have charge, and the charge on the complex means it's only because of the metal. So the metal charge is plus 3. And here Cr hydroxides, this is also a complex, a dative bond is there with the overall charge minus 3. One hydroxide is minus 1, so 6 hydroxide will be minus 6. And one chromium is plus 3, that's why the overall charge is minus 3. So if we have acidified or chromium with the water as a ligand, it's not easy to oxidize, or oxidation means addition of oxygen or removal of hydrogen. So it's difficult to remove hydrogen from the substance or add oxygen. But when it is in alkaline solution, we can easily oxidize. And how we can oxidize this? We can use it, or we can use any oxidizing agent. So it is easier to remove electron from a negative ion. Why it is easy to remove electrons? Because look, this is already a positive complex. From positive complex, because there is also another definition of electron oxidation. Oxidation is loss of electron and reduction is gain of electron. So the substance here, because this is a negative complex, so if it's a negative complex, we can easily remove electron out. This is a positive complex, so it will be difficult to remove electron out. That's why oxidation in acidic medium is difficult as compared to in alkaline medium. Is it clear? Oxidation is a loss of electrons, so we can easily remove electron from a negative complex as compared to positive complex. And then when you have an equation, like example, these are the half equation. When you use hydrogen